Meshing is over. Now we need to apply our loadings on the finite element entities. So we are having the external loading over here is the only one, internal pressure, which is uniform, having a magnitude 250. So we are going to apply that particularly. So we need to apply that particularly from the circumference of this particular circle. So we are going to apply, and how to apply we are going to see it. Say come out of our preprocessor and say solution, a single click. Once we are going for a solution, again we are going to follow a sequence. First option in a solution is analysis type. So we need to set for the analysis type over here, a single click. Now we are again going for the new analysis, say new analysis. In the new analysis we need to set it on a static and just say OK. Once we are setting our analysis type as a static, now we need to go for the defining a loads. So come out of our analysis type and we are going to see for the definition of a loads. So say define the load. Now we need to apply the loads first. So say apply. In the apply we need to go for a structural loading. So we are going to say structural over here. In the structural we are going to apply for our internal pressure. So internal pressure value given over here is a 250. So say pressure over here. Structural pressure. Over here we need to apply our pressure on the nodes, but we can apply that particularly on the lines. So say pressure on a line. So select those internal lines of that particular circle. Select the lines and just say OK. Once we are saying OK, we are having again new pop-up window over here. Now we need to apply for a pressure having a magnitude 250. So we should enter that particular load value over here in front of a pressure column, that 250. It's a uniform pressure, it's not on a varying value. So we should keep it over here itself and supposed to leave it blank. So just say OK on a constant value of that applied pressure as a 250 and just say OK. Once we are saying OK, we are having 4 arrows representing we are applying a pressure over here, but we are needing to transfer that particular pressure value on a nodes. So come out of our pressure, says operate in a defining a load itself, say operate. Now we need to transfer our loadings. Transfer in the sense we are applying on a line entity, and a line is a geometrical entity. We need to calculate each and everything with respect to our finite element entity. That means we need to transfer our loading on a finite element entity, and here the finite element entities are nothing but our nodes. So we are going to transfer our loading on a finite element. So select an option, transfer to FE. FE stands for finite element. Now we need to transfer our loading. So say all solid loads and just say OK. Once we are transferring that one from line to the nodes, we should come out of our command. We are not getting anything over here, but we are having a red colored edge over here. That means our load is transferred on the nodes attached to that particular line. So we need to go for plot control symbols over here. Here we are going to change our representation from face boundary outline to the arrows. Say all applied boundary conditions for a pressure value. We are needing our representation over here as a arrows instead of a face outline, and just say OK. Once we are saying OK, we can see over here that we are having an internal applied pressure which is uniform over here. Once application of external loading with respect to the all load inputs are over, we had already entered for the material properties, geometrical inputs, meshing is already done, and we are applying for the loadings also. Once all things are over, now we need to go for the solution over here. Say solve over here. Say solve for the current load step. Just single click over here, close our status command and just say OK. Once we are saying OK, we are getting one solution note over here that our solution is performed or our solution is done, and just say close it. Once we are closing that one, we should come out of your solution option because our problem or our given numerical is solved with respect to the given inputs, whatever we are specifying over here as a pressure a plate having a thickness 1 and all the inputs regarding to that one. Then we are having this particular plate, we can go for a thickness option because we are knowing that our thickness value given over here as a 1, but still we are not getting a thickness with respect to this particular plate. So we can see over here, just say plot control, style, size and shape. Single click over here. Now switch on our elemental display with respect to the thickness value and just say OK. Once we are saying OK, we can check the difference over here. We are having a thickness of a 1 with respect to that particular element. Thickness is assigned to only finite element entity. That means we are going to get a thickness in a elemental form only. We are not supposed to get any kind of a thickness with respect to the area. We are not going to attach that thickness value to the geometrical entity. If we are going for areas, say plot our areas, we are having a 0 thickness area over here. Whatever the value of that particular thickness we are going to assign will be with respect to the elements only. If we are going over here and just saying that I need to plot for an element, so we are getting our thickness back. That means all the values whatever we are applying over here in a thickness column, all are going to assign with respect to our finite element entity, not with respect to our geometrical entity. So once we had confirmed our thickness, solved the numerical, now we need to see the results with respect to the present solution. Just say general post processor. In the general post processor, we should go for a plot results. Say single click over here in a plot results. Now I need to check for whatever the deformation occurred in this particular structure with respect to the present loading as an internal pressure. So say deformed shape. In the deformed shape we need to go for either deformed shape, either deform plus undeform, either deform and undeformed edge. So we are going to see first as a deform plus undeform. Just say apply. Once we are saying apply, we can see a dotted structure over here is our original one, and blue colored structure indicates a deformed shape over here. If we are going for the next option, deformed shape only over here, and just say apply, we can see only a deformed structure according to the external loadings. And third option over here is deform plus undeformed edge, and just say apply, we can see an undeformed edge inside and rest is a deformed shape. So this is the way we can check for this particular pop-up window what are the types we are getting over here. So we are going to keep it on deform plus undeformed and just say OK. We are having deformation plus original structure parallelly. So we are having a maximum deformation of 0.04 over here. So now we should go for a contour plot, because we are needing our nodal solution with respect to the given input. Say nodal solution. In the nodal solution we are supposed to go for single click over here. Nodal solution, say displacement vector sum, and just say OK over here. So we are getting this much of a maximum deformation occurred in a plate with respect to the external input as a 250 over here in an internal pressure. So this is our displacement vector sum with respect to the nodal solution. Now I need to go for a nodal value with respect to the stresses. So we are going to check for the stresses again. Say nodal solution, single click on our stresses, on which basis we are going to see the stresses we are going to get that particularly. If I am going to say for an x directional stresses, so I am going to say x component of a stress and just say OK. We are having an x directional stresses over here. We can see the output with respect to that particularly. If we are going to see for a y directional, so say y directional over here and just say apply. In that ways we are going to get our stress values varying over here. The most important things over here is we are going to see for non-ANSYS stresses directly instead of going for any kind of an element table also. Just say OK. We are going to get our 1-ANSYS stress value over here plotted. So maximum 1-ANSYS stress, and this is our stress scale. Over here variation is over here from 4.516 to the 941.151. So this is the scale on which we are going to get our stress values which are varying from lower to higher. So this is the way we are going to calculate for the 1 meter stress and the analysis of a plate as a full model. So how to go for an axisymmetric model we are going to see in the next stage.